Good morning, everybody. Today we're going to be working on goodness of fit tests. You're going to need your textbook. You're going to want your calculator with you to be able to compute this. Unfortunately, we need to do this one completely by hand. Some of you, if you have the Texas Instruments 84, will be able to do this on the calculator, but I require it by hand because the 83 doesn't have it, and about half of the 84s don't have it on there. So, as an example, I'm going to do number 9 from chapter 10, section 1. It's on page 533. Let's start off. In chapter 10, all of the tests are right-tailed tests. And the reason is because you're going to be squaring your test statistic. And what happens is that there will be no negative values. So when you do your drawing of your distribution, they will all be drawn so they look like this. So they'll have the high hoop in the beginning, and then they'll have the tail out into the positive section. The number right here at the origin is 0, and even on the F test or the chi-squared test, which are the two tests that we'll be using during this chapter, they're both, again, right-tailed tests, and the rejection region is out off to the right. So number 9 gives us, and I'm just showing you it real quick, I can't get it probably to zoom in for you, but number 9 gives us some proposed percentages right here. It also gives us some values that they were able to sample. What you're going to do with those values is you're going to take the 0.04, the 4% for the Monday, and you're going to multiply it by the sample size, and that's how you're going to get your expected value for Monday, which is 20. You're going to take the Tuesday percentage, which was 6%, we convert it to 0.06, multiply it by the 500, and we'll get the 30. That's our expected value for Tuesday. And you do that for every one of the categories, Monday through Sunday. Real quick. For chapter 10, your null and your alternatives are pretty much prescribed. The null for section 10.1 is it's going to state fits the proposed distribution, and then the alternative is doesn't fit, and that's what's going to happen for every one of the problems. You can get more detailed than that if you want to. I don't need you to. So when you hit the test, just fits and doesn't fit. I'm happy with it. Fits implies the equality, which is standard with all of the null hypotheses, and doesn't fit means not equals. On number 9, when you read through it, you'll see that the claim lands on the alternative. The alpha that they gave us was 0.01. And so you've got to get your critical value. You're going to go to the chi-squared distribution, and let me real quick flip to the page there, and I'll give you the page again. I want to say it is table 6, and it is on page A19. Now the way you get your degrees of freedom for the chi-squared distribution in this case, it'll be different depending on which test you're running. You take your number of categories, which we have 7 days. So we take 7 as our number of categories, and we subtract 1. Degrees of freedom is always minus some number. Generally it's 1. In this instance it is 1. In the next section it's going to depend on which variable you're looking at. Talk about that at another time. So I'm on table A19. Forgive me. Okay. Along the top you'll have your alpha, and along the side you'll have your degrees of freedom. So our degrees of freedom were 6. We traveled on over, and the number that we got out of there was 16.812. So try and make sure you can get that off the table. Now your test statistic that we're going to have to compute works this way. So I'm going to tweak this down a little bit, and I'm going to get it to focus. So the test statistic is computed by doing the sum of observed minus the expected, that's O minus E, and those are in parentheses, and it is squared. That's why you don't have any negative values going on, and that's why it's a right-tailed test, divided by the expected value. So if we take the table and you look at the survey results from the table, we had 43 for Sunday. And I'm going to erase this because I need the space. So 16.812 gets moved up there. So we're going to take the sum of observed minus expected. Now some books will write expected minus observed over expected. It doesn't really make a difference because we're squaring it. The negative gets taken out and the value still is the value. So we're going to have the observed, which is 43 out of the table for Sunday. Sorry. And then we are going to subtract the Sunday value of 35. The 35 is the expected, and we're going to divide it by 35. Now when we're doing the sum of, it means we're just adding them up. So remember we have our squaring going on as well. So the next one will be, we'll do Monday, and Monday says 16. So it's 16 minus, and on Monday is 20 squared over, and again our expected value is 20 plus. Now we're on Tuesday, and the observed value is 25. The expected is 30 plus, and you're going to do that for every category. So I've already done the computation. My test statistic ends up being 17.595. It is our chi-squared test statistic. Now, because we're doing this by hand, we won't get a p-value. So you'll have to base everything off of where this lands. This number, the 17.595, lands in the rejection region. So I'm going to do a quick erase and I'm going to write the conclusions. Step 1. You're either going to reject the null or fail to reject the null, and in this case, because of where the test statistic landed, we are going to reject the null hypothesis. Since we're rejecting the null hypothesis, we're really putting a line through the null. We're getting rid of it. Okay? We always state our level of significance. Alpha is equal to 0.01. And remember again, the default level is 0.05. If they don't give us one, we operate at 0.05. The third thing is we make a statement about the claim. And since the claim did not get a line through it, we're supporting the alternative hypothesis. We say there's sufficient evidence to support the claim. And then what's general practice is you restate the claim. I don't get too hung up about that on the test. So just understand that you're supporting the claim and then what the claim is. Hopefully that's helpful. Have a good day. Oh, also, I have to get this ADA compliant. I'm going to send it to the people that give us the transcription. For a short bit, it may not be transcribed. If you have issue, please reach out to me. Thank you.